Hi, we're going to go over lesson 7-2, parallelograms and point symmetry. So, a parallelogram is a four-sided shape of quadrilateral whose opposite sides are parallel. Okay, so as we go through this chapter, you need to write down the definitions of all these things because they're going to get confusing at the end. So, this one seems pretty easy. The four-sided shapes whose opposite sides are parallel. Okay, so important. Now, really not part of the definition, but I added it in here. All parallelograms have point symmetry. All right, so what's point symmetry? So this is when a figure looks exactly the same when you rotate it 180 degrees or, you flip it upside down. So there used to be this website and they don't do this website anymore, where you could type in a name and it would make it into what's called an ambigram. An ambigram looks the same if you flip 180 degrees. So if you look at this, I tried to spell my last name Provines. And if you look closely and kind of squint a little bit, you can see it, Provines. And so I drew the line underneath it so you could see that when I flipped it, it looked exactly the same. So this has point symmetry. Because it looks the same when it's flipped. So now let's look at some shapes and decide if it has point symmetry. Okay, now again, all parallelograms have point symmetry. Now, usually people want to argue about this first one. Let's just number these. 1, 2. Let's talk about the first three. What do you guys think about number 1? Now, first of all, is that a parallelogram? The only way we know for sure if it's a parallelogram is if the opposite sides are parallel. And so I'm just going to say these opposite sides are parallel. They appear to be. I made it official. So does this have point symmetry? Sure, because we know all parallelograms have it. So the question is, point symmetry, question mark? Yes, it has it. What about a star? Does a 5-pointed star have point symmetry? And the answer is no, because technically, like, this top would rotate down to here, and I'm not doing it that's bad, but it doesn't. Just trust me. Does it have point symmetry? No, it does not. Now, on the next one. Now, this is not a parallelogram. Like, these two sides are parallel, but these two sides are not parallel. So if you were to rotate it, this side would go to here, and then, let's see, that would go here. So it would be something like that. Or I think it actually go the other way, like that. So, no, it does not have point symmetry. All right, what about a triangle? Now, let's just say these sides are all the same. So if they're all the same, is it going to work? What do you think? Well, if you rotate it, it's actually going to look like that. This point goes down to the bottom. So this again is no. And what about a heart? I think you guys are probably catching on. I mean, that's a horrible heart, but if you flip upside down, it's not going to look the same at all. So again, this is no. And I don't know. What do you think about this one? If I were to flip this, does this stay on that side? Now, there's a difference between flipping and rotating 180 degrees. Okay, so if I were to fold it here, yes, it has reflectional symmetry. But if I'm going to take this and rotate it, that would actually come out to this side, like this. So this is a big no. So as you can see, most things don't have point symmetry. Now, would a square and a rectangle? Sure, because technically those are parallelograms. So those do have point symmetry. So let's go jump into theorem 25 and 26. Now, theorem 25, I always call this the combo theorem. The first year I taught out of this book, I really thought it had to be both. Let's read it. It says the opposite sides and angles of a parallelogram are equal. So again, if I ruled the geometry world, I would make this into two different theorems, or one a theorem and one a corollary, because this is dealing with two ideas. So if you have two opposite sides that are equal, so if you have this situation, you're going to say, yes, theorem 25. And actually, I'm just going to leave it. And then we'll draw another picture. That's horrible. Slow down, Mrs. Provine. That's still horrible. Okay, opposite angles. So these two angles or these two angles are equal. You're going to say yes by theorem 25. You don't have to do both at the same time. So again, I don't ever write the word combo theorem, but if you're dealing with a four-sided shape, it has to be a parallelogram, and opposite sides or opposite angles, then it's theorem 25, the combo theorem. Again, I don't get to rule the geometry world, but if I did, these would be separated, but for the sake of consistency of using the textbook, they are together. So I'm going to put a big or here in the middle. You don't have to do both at the same time. The diagonals of a parallelogram bisect each other. Okay, so we know what diagonals are. That's one. Ooh. And that's one. So if they bisect each other, it means it cuts each other in half. Now, my big question is, are all four of these little segments equal to each other? And they're not. This one here is actually going to be much longer than this one. And you can take a ruler out and measure it if you don't believe me. So they are not all the same. So if I label what is equal, we have to label the middle. AE is equal to EC, and BE is equal to ED, but they're not all equal to each other. Hope that makes sense. All right, let's go through this. LM. All right, so this is pretty easy. So here's LM, and we know this is, I want to tell you, this is a parallelogram, right? So opposite sides are equal, so that means this is 13. LP is here, and we know that these diagonals actually bisect each other. So those are equal, so L to P is the same as this one here, so it's 7. LQ is the same as its opposite side, so it is 8. And QP here is the same as this one here, so it's 8.2. Now, at this point, I like to also kind of like justify these with theorems. So let's flip back and look. So what justification tells us LM is going to be equal to QN? All right, so opposite sides are equal. That's the combo theorem. Do you guys remember that theorem number? Theorem 25, right there. Good. All right, LP. All right, so this is the diagonal bisects one. These two are equal, these two are equal. So that's the one right after it. So that is theorem 26. LQ, we knew that because the opposite sides are equal, so that's back to theorem 25. And PQ, that's the diagonals bisect, so that is theorem 26. All right, go ahead and do your homework for lesson 7-2, and let me know if you have any questions. Bye.